Hi, my name is Erin Gibbons, and I'm here to talk to you today about coping with a heating planet. I started this work as part of the Climate Justice Institute. This work was done in the fall of 2021, and that was led and facilitated by Heather Price and Sonia Doucette. And some of the work in this slideshow was also done by Heidi Overman, as well as several other colleagues in the Climate Justice Institute. With this video, I hope to set the stage for climate justice topics and prompt you to think about your own position relative to the changes that we can already observe as well as those to come. I also hope that we can become more engaged as citizens, supporting each other to create the community action that will be necessary to solve our biggest, most tangled problems, and also to maintain hope, despite what can feel pretty scary. A tangled problem is one that's very complex, so it takes a lot of time to understand how to approach solutions. And when we enact solutions, occasionally we may actually create new problems. So, to stay engaged in that process, we need to work with other people who are making a difference and recognize that our individual efforts work within the greater movement, which is led by many smart experts. So, where are we in this era of fossil fueled climate, and how do we cope with a heating planet? Let's take a look at these newspaper article dates. 1912. We've known from a long time that the planet is warming as a result of fossil fuel combustion. Here's an article from 1912, Coal Consumption Affecting Climate. Here's an article from 1952, It'll be warmer and drier. We've seen evidence gathered by fossil fuel companies around 1980 about their knowledge that burning coal, oil, and gas was causing heating and that it was going to impact societies on a global scale. This presentation was created in the fall of 2021, and since that time, the news about climate disasters has increased a lot. In addition to the course outcomes, this assignment has some outcomes relating to your awareness of what you know, of what you're willing to do, what you know how to do, and the things that you care about. From today's work, I want you to understand the problems arising from rapid global heating, as well as how you fit in as someone who experiences it and someone with a clear role and ability to contributing to solutions. In other words, where is your power and what do you care about? Understanding the social impacts of the recent heat waves teaches us that we can take action to keep our neighbors safe, to keep ourselves safe, and to build that sense of community reliance and resilience. In terms of chemistry, we can consider energy, such as heat flow, for example, during phase changes. I'd also like you to be able to find data and verify data, to recognize correlations, to understand the social and legal aspects that come into play, and more importantly, how to support claims or evaluate information that you're given. Things like verifying the data, analyzing the data, vetting your sources, and being able to understand information in a scientific way so you can make informed choices relating to your own safety, your own consumer habits, and any activism you want to support. For example, predicting heat flow. Where do you want to spend your time if the weather is forecast to be excessively hot? Opening and closing blinds can help you regulate your heat, opening and closing windows, or knowing how to help somebody who's in heat distress, to recognize the signs and how to help them cool down quickly. Moving into the engaged citizen part, being informed voter and understanding how to support equitable climate resilience, as well as sharing that information. Are you willing to have conversations to share the information that you learn with friends, family, community members, and practicing your science communication? Your work might look something like this for this assignment. You'll pick your own adventure. There will be many options for assignments, so you can pick what you'd like to focus on. You'll pick your own area to investigate and which of these outcomes to focus on. I'd like you to address at least two different outcomes. So one will be the content area with the chemistry question, and the other will be civic engagement and climate justice outcomes. So for example, on the chemistry side, you might describe how evaporative cooling works, and then pick a second outcome from civic or justice outcomes listed on that previous slide. So this might be your collection. Develop awareness about the dangers of excessive heat and resources for coping with it, and develop understanding of who is most vulnerable to excessive heat and how to mitigate those inequities. The class assignment will clarify more details about your forum post, but as we move through these slides, think about what you'd like to know more about, which subset of these outcomes you want to focus on. Often there are resources in the slides that you can follow up on to craft your forum post. This graph of NASA data shows the temperature anomaly compared to the baseline of the 20th century average global temperature, which is the blue line there, the 0. This is showing that 19 out of the 20 hottest years on record occurred between 2000 and 2020. So very recently. As I record this video, we just experienced several days in July of 2023, which each set the new record for the hottest day ever recorded globally. You can find more recent data at this link down here, and you can generate your own graphs using the NASA data. As you see here, 1976 was the last time that the average annual temperature was below the 20th century average. That means if you were born after that time, you have never lived in a world that had the average temperature from the 20th century. It's always been warmer than that average in your entire lifetime. Who do you know that experienced that average 20th century weather? So let's talk a little bit about graphing. Let's take a look at these axes. This is going all the way back to 1880, and the last year of data was 2020. Do you think that this 20th century average would be similar to the 19th century average? Just looking, here's 1900, so just looking at the last 20 years of the 19th century, it looks like maybe global warming had already taken place because that average is significantly higher than all of those points. And what is the temperature anomaly anyway? Why is that 0? What does that mean? It goes up to 1.0 here. That's something to think about. So this is lower than that average and higher than that average. So it's always a good idea with graphs to think about, what am I really looking at here? For those of us in Seattle in June of 2021, we saw the number of days over 90 degrees in June had doubled since record keeping began. We had record sequential days over 108 degrees that year, and mussels were literally baking open on the rocks. In this picture, you can see this person has placed aluminum foil over their windows. How does that work? Why are they doing that? And extreme heat is linked to lower cognitive performance in students if they're working in classrooms without air conditioning. Let's take a look at the heat map here in red and the income map in green. And here is a link where you can make some of these maps. What do you notice? So the red shows the surface temperature. The dark red is hot, right there in the Duwamish waterway. And the cooler areas are white. What are these white areas where it's cooler? Compare that to the green. So let's see, nice dark, that means high income, Laurelhurst. And it's pretty cool. It's pretty cool. We see that high income right around the Ship Canal Bridge and also along the waterway there. But down here, it's a lower income near that Duwamish area. So interesting to see how those almost overlay each other. 1 in 3 Americans experience a climate disaster in the summer of 2021. That's a third of us, and it's probably more since then. that include massive flooding, heat waves, wildfire, and smoke. We see from this map that the country was drier in some places and wetter in others. So we see this polarization, this separation of excessive dryness and heat and then major flooding. So this was a photo from Paradise, California, before and during the fire. That was one of those disaster events. And we've seen global increases in heat waves and flooding since. In 2021, there was Hurricane Ida, which spanned several states from Louisiana to New York and flooded them all. And let's take a look at wildfires. Of the top 20 largest wildfires from 1932 to 2021, the first three were in black and gray. Three still made this record of the top 20 biggest fires. They took place between 1932 and 1999. Then in the first 20 years of this century, we had 8 of the largest wildfires, and they're getting bigger. These slices are skinnier. This is huge. California had 5 of the largest wildfires in 2020, and then 3 of the biggest wildfires in 2021. It's pretty rapid change, wouldn't you say? And did you know that it had changed that fast? Does your family know? That might be worth talking about, just sharing the conversation. We see that global climate change directly impacts our health and survival. It's in the news a lot now. For example, this family in California was found dead on a trail they knew well. They went hiking with their daughter down to a river on their property, and about midday, they decided to hike out, go home, and they had water with them, but they were caught by surprise at how the excess heat affected them, and they all died of hyperthermia. They were found dead on that trail on their own property. So that's pretty startling to go on a hike with your family and die, all of you die. That's what excessive heat can do. And also, a woman that year, this is also summer 2021, a woman in Seattle died in her home, and her neighbors were quite shocked. They didn't think that anything was wrong. They knew she was elderly, but elderly people are more vulnerable to excess heat. So you can watch this news clip at the link there. So in the heat dome of 2021, more people died than anyone had died from a weather event in Washington since the avalanche in 1910, and 96 people were killed in 2 trains in an avalanche. 159 people died in Washington, and that is probably an undercount. Those are the people connected directly to heat. We know what the causes are. We know why this is happening, and we know what we can do about it, what we can do individually and what we can do collectively to improve the situation. We know that carbon dioxide emissions, mainly from transportation, cause the heating that is giving us these extreme weather-related events. Other greenhouse gases contribute as well, especially methane or natural gas in particular. That is an important one to talk about. So individually, you can check on your neighbors, and when you see someone suffering from extreme heat, you can identify the signs and know how to cool them down using what you've learned about phase changes and heat flow in this class. You can also research your own personal choices about where you spend your time in excessive heat, how you manage heat flow in your home if you don't have air conditioning, and how to save electricity so that the grid isn't taxed during heat waves. Know what generates heat and how to cool a room down. And also, you can be informed when you vote. You can research the information and take a stand on local issues, and that makes a big difference. We'll see a little bit of that. So this extreme heat is tied to human-caused climate change. This is an area that some of you might like to investigate further. You can see in this graph here, the observed temperature anomaly is the black line. So that black line, here it's pretty close to the zero, it's kind of bumping around, and then it starts to get higher, and we see it going up. Now we also have natural drivers in blue. So the blue are regular patterns of heating and cooling and other natural drivers, maybe volcanic activity and that kind of thing. Human drivers are in red. So those will be our greenhouse emissions, carbon dioxide from the Industrial Revolution, and those are going up. And the black observed temperature anomaly is going up. While the natural drivers are still variable, but they're closer to that average line. So we can see clearly that this is human caused. It increases right along with the human caused emissions. So that would be carbon dioxide emissions, mainly from transportation, and methane. Those started going up rapidly about 1960. So the sum of all those drivers together is the orange line, and the observed heating tracks that pretty closely, except in recent years, where the observed heat goes up dramatically more than the sum of those drivers. So we know it's humans causing this, and in one sense, that's a hopeful thing because we know we can also make changes. So which populations are more vulnerable to excess heat? Well, older people are very vulnerable. Very young people can be vulnerable. Anyone without appropriate housing, farm workers, and others who work outdoors. Anyone who can't afford to stay home during excessive heat, they have to work. Maybe they work outside. Those people are vulnerable to excess heat and heat-related illness that can result. Access to air conditioning can be a lifesaver. In that Heat Dome 2021, there was a study in Portland that showed that of the 54 people who died, immediately from heat-related deaths, none of them had central air conditioning. So air conditioning can save people's lives, but not everybody can stay home, not everybody can afford to have it on, and not everybody has it in their homes. Also, remember that using air conditioners is one of the biggest contributors to greenhouse gases and human-generated climate change, so it's not an ideal solution, but it does help us keep our loved ones safe. And one thing you can do for elderly or people who can't afford air conditioning, you can take them to a community center or a cooling center or a mall, someplace that has, or a library that has air conditioning, so they at least get a chance to cool their body down. This link down here gives an interactive heat map, so you can check that out. And we know there's an equity problem from the relationship between heat and income within cities. So here we have Oakland, and on the right we have Los Angeles. In Oakland, up in that cooler section up here, that's the Berkeley Hills. Lovely, beautiful neighborhoods, expensive homes. It's a high income area with lots of trees, forested right up against the hill. But in downtown Oakland, where that heat island, that dark red, that's the low income area. And in Los Angeles, we see the same kind of inverse relationship. You could overlay these and they would completely fill each other out. So we know this is related, we know this is a problem, and we'll talk about why in just a sec. But let's talk about action. What can you do when it's dangerously hot? You can check in on your neighbors. If you know someone who lives alone, check in on them when the weather is excessively hot. If they don't have air conditioning, maybe take them to a mall or a library so they can get cooled off in the hot part of the day. And you can help them adjust their home to stay cooler by closing blinds and windows during the day or opening windows at night if it cools off. I personally rotate a fan in my window to blow out the late afternoon heat, and then I turn it around and blow cold air in in the cool morning. You can think about your own home and how you can adjust your window coverings and your fans, opening and closing windows to make sure that your home stays as cool as possible without air conditioning. And if you observe signs of heat stress, to help someone cool immediately, so for example, with a sponge and a fan, it's important to get their bodies cooler for at least a few hours by visiting a place with air conditioning. This is especially important if you don't have cool nights. And on the community level, the city of Seattle opens several cooling centers, and other cities do that regularly. You can find out where those are and share that information with your neighbors. So that's one way to strike up a conversation about these topics. In case they had not thought about going to a cooling center, normalize helping each other out and discussing options when hot days are predicted. If someone can't afford the utility bills to run their air conditioner, they can access assistance programs as well. So, what are some of the things that you can directly do to help the people around you if you find someone in acute heat distress? Well, connect back to the energy of phase changes and how heat flows. How does sweating work? Why does a fan feel cool? What does the ambient humidity have to do with the effectiveness of sweating as a heat loss mechanism? Is it easier to cool the body down in a dry condition or in humid conditions? And when are fans an effective cooling strategy? These are all choices you can comment on to make your post in the forum this week. And finally, moving into some opportunities for civic engagement, you might be interested to learn about the connection between heat islands and income, which is tree coverage. Here we compare the surface temperature map with the tree coverage in Seattle. These cool areas on the coast, right, all along that coastline, well, they're windy, they have a lot of trees, and these are also wealthier neighborhoods. They have nice views along the coastline there and plenty of trees. The red heat islands show up in parts of the map that are gray. Down here in the industrial area near the airport, there's a lot of heat trapped in that concrete. The lack of tree cover can make a neighborhood hotter. The cement will absorb the heat, hold it, and release it slowly, whereas trees provide shade and retain moisture. Currently, our local politics point to saving trees as potentially in conflict or as an obstacle to increase low-income housing. But it seems to me that if we want to have both of those things, that people who live in low-income housing should have access to tree canopy as well. In addition, maintaining our trees in those low-income areas will help keep the city cool on the whole. And these tree canopy maps correspond directly to the race and ethnicity of the city. So there's the connection to the justice piece. The low-income areas are likelier to be hotter than the wealthier counterparts, and usually those are the communities of color. That's another area where you can take direct personal action. You can get involved in your community and make a significant difference. As I speak right now, um, there's currently a dispute over a mature tree in the Wedgwood neighborhood being cut for a 6-unit development. And somebody is up in the tree, sitting in the tree to prevent it from being cut. So it might be that that developer needs to redesign how to get those 6 units on there without cutting that tree. And we'll see what happens. That's an area where community is getting involved in the decision process. Last year in Shoreline, there was a community outreach to save some trees. It was a stand of mature trees in a spot where they wanted to widen the sidewalk. And that seems like a great idea. But they were going to cut down all the trees and replace it with a wide concrete sidewalk. There was a significant community outcry, and they ended up spending a bit more money on the project. They took more time to redesign it and made several improvements. For example, they sourced the concrete more locally, which was a greener way to do construction. It ended up saving them costs because they didn't have to pay for fuel to ship the concrete to Washington. So that's a double win, reducing those emissions and also paying less. So the outcome was that they redesigned the sidewalk, and the cement piece was a little bit narrower so that they could keep the trees, and they used wood supports to hold up the cement instead of cutting through the tree roots. And by doing that, they were able to save the whole stand of mature trees and still build the sidewalk. But it did take community participation in that review process, and the community insisted they design something that could retain those trees. So it really does make a difference when people show up. Prioritizing tree canopy in local decision making is an area where you can make a direct impact on your local heat island effect. So read the notices around your neighborhood, participate in local events and discussions, stay informed, and if you can vote, vote. If you can't vote, you can still sign in and give your opinion about legislation on the website, the legislators' website here in Washington. When we act in support of the things we care about together with our community, it helps alleviate some of the anxiety we face as we try to solve the climate crisis. Here are some references from what you saw in the slide set, and thanks so much for your attention, for all you do to reduce fossil fuel emissions, and for creating the social movement to make this shift happen. Take care and stay cool.